Hello everyone. We'll start with the subject basic geotechnical engineering. 18CV54 is the code. We'll go to the next slide. So this is subject to be learnt under BE Civil Engineering or BTU under the scheme Choice Based Credit System CBCS, and it is an outcome based education. The name of the subject is Basic Geotechnical Engineering. Course code is 1854. Continuous internal assessment will be having 40 marks. Semester end examination will be having 60 marks weightage. Actual exam is conducted to 100 marks, but it is reduced to 60. Credits you will be getting would be 3. Exam hours will be 3 hours. Okay, if you look at the syllabus, it has got 5 modules. Module number 1 covers introduction, like what is geotechnical engineering, what are the different parts of it, how it is applied, why it is needed for civil engineering, etc. will be introduced. Then soil, how it is classified, what are the theories which are to be developed. With the very basic thing, it will be started. Module 2 will be a soil structure and clay mineralogy, and then compaction. There are 2 bits into this. Module 3 has got 3 bits: flow through soils, seepage analysis, and then effective stress analysis. Module 4 has got shear strength of the soil. Module 5 talks about consolidation of the soil. Overall, if you look at the syllabus, it starts with very basic idea, and gradually the physics concepts are applied to soil to study the soil. So in the beginning we'll study why this is separately studied as soil mechanics, why it doesn't be covered under strength of material, etc. Those parts we'll be studying in detail. The geotechnical engineering subject has got outcomes, course outcomes, means after the student studies the subject thoroughly, if he gets through, he should be able to understand the index and engineering properties of the soil through the 3-phase system of the soil. The second outcome would be apply the theory of compaction in the selection of suitable soil and know the structure and clay mineralogy of the soil. Then applying Darcy's law in determination of permeability, effective stress and construction of flow nets is studied. The student will be able to analyze for shear strength of the soil and study various methods to determine the shear strength parameters, like box shear test, unconfined compressive strength test, triaxial test, vane shear test. Then finally he should be able to understand the one-dimensional contortion theory and classify the soil accordingly. This is overall what are the course outcomes means after the study of the subject what the student will be able to, that is the concept. Okay, we'll start with basic geotechnical engineering 1854. We'll start what is this, what is there in that, why it is, etc. What is geotechnical engineering? Okay, geotechnical engineering is a combination of physics, earth science, solid mechanics, geology, etc. So mainly it is the physics concepts which are applied to rocks and soil. That's why it is called geotechnical engineering. Earlier, only soil was taken as a subject, and then we used to call that subject as soil mechanics, and rock mechanics was studied separately. Now, soil and rock together, wherever there is earth comes into picture, so it is called geotechnical engineering. Geotechnical engineering comprises of soil and rock mechanics. It involves application of theory of soil mechanics to variety of field problems. Now, what are the field problems that civil engineer comes across? What a list over here. It is safety of the building foundations. Now, when you want to construct buildings, obviously a lot of money and time is being invested for some good purpose. So it has to serve the purpose for a really good amount of time, and the nuisances like earthquake or any other natural disturbances should not easily affect the building. The building should stand erect and give its service properly. So for that purpose, obviously the foundation is very important. So in the design of foundations, we need a theory. First of all, understand the soil which is there, which the building is being constructed, study it properly, and then we should be able to make a decision whether we can go ahead with the construction of a proposed building. If not, then what are the remedies? So those aspects will be studied. So safety of the building is most essential part, and it is a domain of geotechnical engineering. The foundations for not only buildings but any kind of structure that you build on earth surface, for example dam, for example bridge. So like that, any structure that you imagine to construct, even offshore structures, when they are constructed below the water level, it has to be founded on the seabed. So because of that, wherever there is a term foundation comes, so design of foundation is a domain of geotechnical engineering. Foundation, the word foundation is used for the part of the structure which uh, transfers the load of the structure to the ground or earth. So inside the earth you may be having soil or rock or a combination of that, right? But the foundation has to be designed in such a manner that the soil will be able to sustain the load of the structures in general. Next idea is safety of slopes and cuts. Now here a photograph shows there is a road already constructed, but the side slope has collapsed because they have not taken care of, or in the beginning it was fine, but because of some natural phenomenon the slope has given away and then it has collapsed, disturbing the traffic. This shouldn't happen. So we should be able to judge whether it is safely done or not. Otherwise, we have to make some or give some remedies so that the cut slope or embankment slope, this is a cut slope, even this is an embankment slope. Let's say artificially, if it is dumped and then a road is created, then also. So whether it is a natural slope or whether it is a cut slope, whatever maybe the way the slope of soil or rock is there, how safe it is, that is what we are going to study. Safety against settlement. Now this is famous building, everyone knows that it is Leaning Tower of Pisa. So here the major problem is the soil on this side is more compressible. Because of that it has settled, whereas on this side it is not settled. So it is interesting that if whole of the strata was equally uh, bad or equally compressible, then the building would have gone down. Then there wouldn't have been much of hue and cry. Only because part of the foundation is on different soil, and then part of this foundation is on a different kind of soil, this particular structure is bending on one side. Next is safety against flow of water. So as a part of syllabus, we'll be studying what is seepage analysis, etc. So why it is studied is, suppose you want to build a dam, and then if it is an earthen dam or a rock and earth dam, the huge height of the building you imagine you have constructed, and then if the water is stored in rainy season, and then if there is a lot of permeability, that is flow of water is possible in the dam, then the whole of the water will be discharged on the other side easily in very little time without serving the purpose, because the dam is constructed and then store the water so that it can be used for months together, almost year long, so that next rain when it comes it will be able to fill the dam. So this is the aspect, like how much is the permeability or the rate of flow. One more case is suppose if you want to build a building below the ground level, and you will be obviously excavating. When you excavate, there will be, if the water level is quite above, then again you have to apply some remedies like pumping out, etc. What rate of pumping is essential. All these calculations depend upon what is the rate of flow inside that pit that you have made. Even in civil engineering, we'll be studying water resources also. So one of the major water resources is groundwater. So when you make a well or a tube well, so what is the rate of flow, and what is the yield that we can depend upon? So this is nothing but permeability of the soil, or what is the rate at which the soil will be allowing the water to pass through. And then there are many other aspects also. If the water is present, how the soil behaves, whether it will be gaining strength, it will be good for using the soil. If it is getting dried up, then what? So like this, there are many things that will be studied in detail. So at the end, what we can say is geotechnical engineering comprises of soil and rock mechanics. It involves application of theory of soil mechanics to a variety of field problems, namely building foundations, safety of slopes and cuts, safety against settlement, and safety against flow of water.